Solve the given inequality. This is a rational inequality. Present your answer in interval notation. All right, the first thing that I need to say is a reminder of inequalities. So if I had like negative 2x is less than 4, and I did a divide by negative 2, you know to switch the inequality. So it's important to know that when you multiply or divide by a negative number, you have to switch the inequality. A very common first mistake is to clear fractions. I'm putting this in red because it doesn't work, and I want to demonstrate why it doesn't work. So multiplying by x plus 4 appears to reduce the fraction, which is better than a rational expression. However, is x plus 4 positive or negative? If it's positive, we keep this inequality sign pointing to the left. If it's negative, we switch it. But since it has an x variable in it, we don't know. So therefore, we're now in an unknown situation. We don't know, should it be this way? Should it be this way? This suggests that we shouldn't do this step because we don't know if we're doing it right or not. Now, I have seen people fix this situation by multiplying by the square of the factor x plus 4. It was a very creative solution that I saw. It does lead to a little bit harder algebra, but what it does do is now I know that this is positive, because when you square a negative or a positive or 0, you get non-negative. So it's non-negative, so that we know not to switch the inequality. However, that does lead to a little bit harder problem. So in general, the thing to do with these rational inequalities is don't try to clear the fractions. Hopefully this makes sense why if you did try to clear fractions, you missed some points and got the wrong answer. Multiply by only what you know the value of. Know that it's positive or negative, so you know what to do with the inequality. All right, so how else do we do this problem? The other method is to not try to clear fractions at all. Instead, just start working with the fractions. So I'm going to add the 4 to the left side. Let me move that over a little bit. I now need to create a common denominator so I can add these fractions. So I multiply by x plus 4 over x plus 4. That's a form of 1, so it won't change the value of the 4, but it does allow us to add these fractions together. So they will have the common denominator x plus 4. This is 4x plus 16. We can combine the numerators. 4x minus 3x is x. Negative 5 plus 16 is plus 11. So we now have a rational inequality where it's one fraction less than or equal to 0. The way we handle this is with a number line with the x-intercepts. That would be negative 11, and that, because of the equal sign, can be included. So I'll make that a solid dot because that would make the value 0. And the negative 4, because it's a denominator issue, we would have to have that a hollow dot. And now we go through and just test some points. For example, testing 0, 0, that would give me 11/4. That's positive. If I try negative 10, that would give me a positive on the top, 1, and a negative on the bottom. Positive and a negative makes a negative. And if I tried like negative 50, it would be a negative over a negative. That's positive. So I'm not worried too much about the value, just the sign of the value if we plug this in. So technically plugging in 0 gives us 11/4. But I just need to know that it's positive because I want to know where the final answer is less than or equal to 0. Those are the negatives. Combining the endpoints as they are, we can now draw our solution in interval notation. It is from negative 11 to negative 4, hard bracket negative 11, soft bracket at negative 4. Okay, now for a little bit deeper picture into this, we're actually dealing with a horizontal and a vertical asymptote and an x-intercept situation. Oh my goodness, then I can't graph it. There we go. That's the graph of this rational expression, x plus 11 over x plus 4. And we're looking for where is it less than or equal to 0. So it's only this little region here where it's below or on the x-axis. So that's really what this sign, number sign analysis is giving us, is a one-dimensional approach to looking at a two-dimensional graph. All right, hope this helps.